Okay, hi there everyone. For our session today, we will be having problem solving involving geometric sequences and series. Now, let's begin with our first problem. Chain text messages operates the same way as chain letters. So I'm going to give you an example of a chain text message that I have received last week. So here it goes. Send this to 10 of your closest friends and your friendship will last longer within 1 hour. I have another chain text message that I received a few weeks ago. Send this to 3 of your family members and you will have a bountiful life. Send this within the day. So those are examples of chain text messages that I have received or probably have received. So when I say, let's go to our problem. One such chain text requires a recipient to send the message to 3 other people within an hour. So if example, this started with one person. After an hour, that person has sent the chain text to 3 different people. So at 8 a.m., there will be 3 people who will receive the chain text message. Now, each of these 3 people will then again forward this to 3 of their friends or 3 of their contacts in their chat. We have 3 for the second, and we have another 3 for the third person. So during 9 a.m., there will be 9 people who will be receiving the chain text messages. As we go along with our sequence, you all know that to get the next term, we will be multiplying this by 3. Multiply this by 3 to get 9. So to get the number of people who will receive the text at 10 p.m., I'm going to multiply 9 by 3 to get 27. So if I'm going to continue the process, the pattern, so at 11 a.m., there will be 27 times 3, that is 81. So you have 81. Now, next, at 12 noon, how many people will receive the chain text? So that is 81 times 3. You will get 243 for that. 243. So let's continue. At 1 p.m., how many will receive the text or the chain text? So, sorry for that. So 243 times 3, you will be getting 729. 729. At 2 p.m., so I will multiply 3 to 729. And you will get 2,187. At 3 p.m., there will be, times 3 na ako ang 2,187, I'll get 6,561. And this will answer our problem because the problem states how many people will receive the chain text message at 3 p.m. So at 3 p.m., there will be 6,561 people to receive the chain text message. Okay? Now, this is the first way of solving this problem. Another way is using the formula. Now, as you have noticed, this problem is a sequence problem. Why is this not a series problem? Because I did not add 1, 3, 9, 27, so on and so forth to get 6,561. I simply computed the nth term, which is This is the formula for the nth term of a geometric sequence. First term, Rn minus 1. So, let's identify the given first. The first term is this one, the number 1. The common ratio, the number we multiplied, that's 3. And our n is, okay, from 7 to 3 p.m. we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So n is equal to 9. Substituting everything to your formula, so you'll be getting a sub 9 is equal to the first term, that is 1. And we have the common ratio, that is 3 raised to 9 minus 1. And take note, you will be getting 3 raised to 8 for this. Now, what is 3 raised to 8? 3 raised to 8 is equal to, it's the same answer as we had a while ago. 6,561. So again, you can do the listing method, or you can make use of the geometric sequence formula. Let's proceed to another problem. The problem that is similar with this, but I have changed the question. So this is still at 7 a.m. We have 1, then 3, we have 9, and we have 27. Okay? Now, here is the question. How many people will receive the chain text message from 7 a.m. to 3 p.m.? So the given is still the same. The first term is still 1. The common ratio, that is 9 divided by 3, that's equal to 3. And our n is equal to, from 7 a.m. to 3 p.m. You count 7, 8, 9, 10, 11, 12, 1, 2, 3. There will be 9 numbers there. Okay? So, is this a sequence formula or a series formula? This is now a series problem. Okay, this is now a series problem. Take note, we will be adding the number of people from 7 a.m. until 3 p.m. because we are after of how many people receive the chain text from 7 to 3. Okay, so I will be using the geometric series formula, which is this one. There you go. And substitute everything to your formula. So S sub 9 is equal to, the first term is 1 times 3 raised to 9 minus 1 divided by 3 minus 1. Okay, solving everything using your calculator. So 3 raised to 9 minus 1 times 1 divided by 3 minus 1, that's 2. The answer is 9,841. And this will be the answer to the problem. So there will be 9,841 people who will be receiving the chain text from 7 a.m. to 3 p.m. Okay, let's have another example. This one. During an initial phase of an outbreak of a certain virus, the number of infections grow geometrically. So we have here 4, 8, 16, so on and so forth. Take note, these are the first 3 days. First day, second day, third day. How many were infected on the 10th day? So let's write down the given first. The first term is 4, correct? The common ratio, that's 8 divided by 4, that's 2. So we will multiply 2 for that. And the value of n is 10. Now here's my question. Is this an this is a sequence formula? Or is this a sequence problem or a series problem? That's totally right. This is a sequence problem because we are only after of how many infections are there during the 10th day. I'm not after of the total number of infections until the 10th day. I am after of how many were infected on the 10th day, during the 10th day. So this is a sequence formula again. So this is the formula for the geometric sequence. And there you go. Substitute everything to your formula. A sub 10, the 10th term, that is the first term. We have 4. The common ratio, that's 2. Then we have 10 minus 1. So we have 4, that's 2 raised to 9. Solving this one, 2 raised to 9 times 4 will give us 2,048. So there will be 2,048 people who will be infected on the 10th day. Okay? Now, let's have the same given, the same words, the same sentences, but I will be changing the question now. Look at the question. How many were infected for the past 10 days? So let's write down the given first. The first term is still 4. The common ratio is still 2. And the value of n is still 10. Now, here is the question. Is this a sequence problem or a series problem? So take note, we are referring to the past 10 days. So meaning, day 1 plus day 2 plus day 3 until day 10. So this is a series problem. And our formula for geometric series is this one. There you go. That's r raised to n minus 1 all over r minus 1. Substituting everything to the formula, this is now the sum of the first 10 numbers. We have the first term, this is 4. R is 2 raised to 10 minus 1 all over 2 minus 1. So solving this one in your calculator, 2 raised to 10 minus 1 times 4 divided by 1, since 2 minus 1 is 1. The answer is 4,092. Therefore, there will be 4,092 infected people during the past 10 days, from day 1 until day 10. Okay, let's have another problem. We have this one. A ball is dropped from a tower. This table here shows the height of the ball's bounces. So, bounce number 1, 300 centimeters. Bounce number 2, 150 centimeters. Bounce number 3, 75 centimeters. And this forms a geometric sequence. The question here is, what is the height of the 6th bounce? So let's identify the given first. The first term is, of course, the number 300, the first bounce. The value of r, that is 150. This is 150. Let me erase that first. Okay. Okay. Let's continue. This is 150 divided by 300. So, kini siya gi-divide ana. We will get 0.5 for that, right? Now, what is the value of n? The value of n is 6. Now, here's the problem. Is this a sequence problem or a series problem? Look at the question. What is the height of the 6th bounce? Okay, this is a sequence problem. And this will be the formula for the geometric sequence. Substituting everything to your formula, this is n. Take note, that's n. Sorry. A sub 6, the 6th term, 300 times 0.5 raised to 6 minus 1. Take note, this is equal to 5. So 0.5 raised to 5. Multiply that to 300. You will be getting 9.375. What if I will let you round this off into one decimal number? You will have 9.4 centimeters for this. So this will answer our problem. 9.4 centimeters during the 6th bounce. Okay? Let's have another problem. Here's another problem. A table shows a car's value for 3 years after it is purchased. Now you have noticed that the value of the car is decreasing because any car or any appliance that you will buy, that depreciates, meaning its value decreases as time goes by. So this is the first year, 10,000. So that is A sub 1 is 10,000. So we have the common ratio, that is 8,000 divided by 10,000. How much do you get for that? You will be getting 0.8. 0.8 for that. Okay? Now, what is the value of N? 10. And it is asked again, what is the car's worth during the 10th year? So I will be solving again. This is a sequence problem. Let's write down the geometric sequence formula. Substituting everything to your formula. This is A sub 10, the 10th year. 10,000. This is in dollars. Take note. This is US dollars. R, that's 0.8. Raised to N minus 1, that's 10 minus 1. This becomes 9. So 0.8 raised to 9. Multiply that to 10,000. That is approximately $1,342.2. Okay? So this will be the price of our car during the 10th year. Okay? Now let's have another problem. A pendulum swings 10% shorter than its previous swing. If its first swing, so we have here our first swing, 24 centimeters. 24 centimeters will be our first swing. So take note, 10% shorter. So I'll be having 24. I'm gonna get 10% of 24. That is simply 24 times 0.1, because 10% can be written as 0.1 or 0.10. Okay? So I now have 2.4 for this, right? So what will I do with this? I will be subtracting 2.4 to 24 to get the next number to 24, because 24 will decrease when mugamay man siya, 10% shorter. So meaning, I will be having 24 minus 2.4, which will give me 24 minus 2.4 will give me 21.6. 21.6. So this is 21.6. Okay? Now, if I'm going to be getting the third number here, so the same process. You get 10% of 21.6. So I'll multiply this by 0.1. And I will be getting 2.16. And I will subtract 21.6 by 2.16. So 21.6 minus 2.16. That will give us 19.44. 19.44. Okay? Now, let us get the common ratio. Diba? To get the common ratio, we will divide. So that is 21.6 divided by 24. So, meaning, I'll be having 21.6 divided by 24. You will get 0.9 for that, right? 0.9. How do you write 0.9 as a percent? Diba you can write this as 90%. Now here's my question. How can you solve 90% without passing through this process, without showing this, the whole process here, without showing this? How will you get the common ratio? It's so simple. You focus over the percent, the 10% there. So the common ratio is simply 100% minus 10%. That will give us 90%. And 90% is written as 0.9, which is our common ratio. So there's no need for us to compute this. It's simply 100% minus 10%, that's 90%. Convert to the decimal, that's your common ratio. Okay? So the question here is, how long will its ninth swing be? So meaning this is a sequence problem. A sequence problem, so this is the first term, r raised to n minus 1. So I have the ninth term, that is the first term is 24, raised to r, that's 0.9. Then you have 9 minus 1. So solving this is equal to 8. So I now have 0.9 raised to 8. Then multiply that by 24. You will be getting 10.3 for that. So meaning the ninth swing is 10.3 centimeters. Okay? Let's have another problem. Here, a car's value depreciates by 12% every year. The word depreciates is the same as shorter or decrease. So meaning the common ratio is 100% minus 12% will give me 88%. So the common ratio is 0.88. Okay? Now, what are our other givens? The first term. The first term is how much is the car? The new car cost how much? 560,000 pesos. Now, after 6 years, so we have n is equal to 6. Okay? Now, solving this, this is still a sequence problem. A sub n is equal to a sub 1 r raised to n minus 1. So I now have a sub 6 is equal to the first term, that is 560,000. I'm going to multiply this by r, which is 0.88 or 0.88, raised to 6 minus 1, which will give me 5. So 0.88 raised to 5, multiply the result to 560,000, you will be getting 29529.9. This will be the cost of the car after 6 years. Okay? Let's have another problem. A ball tossed to a height of 4 meters rebounds to 40% of its previous height. So if I'm going to illustrate this, if this is our ball, it will, until such a time that it goes back, it moves down. So going up, it's stated in the problem, a ball is tossed to a height of 4 meters. So going up will be 4 meters. When it goes down, it is the same distance as going up. If the going up is 4 meters, meaning the going down is also 4 meters. So meaning the first flight, the first toss of the ball, this is 4 plus 4 will give us 8 meters. Now, let's continue. The ball bounces back. The ball bounces back. Now, when it bounces back, mas mugamay iyahang na-travel going up. So meaning, it is stated here, the ball rebounds to 40% of its previous height. So what is 40% of 4? Because 4 is the previous height. So I'll multiply 0.4 and 4. 4 times 0.4 will give us 1.6. The same as going down. This is 1.6. So 1.6 plus 1.6 will give us 3.2. So if I'm going to continue with my illustration, going down, going up, so that's 40% of 1.6, which is the previous height. So 1.6 times 0.4. How much is that? That's 0.64. 0.64. This side going down, 0.64. So I'll be getting 0.64 plus 0.64, which is 1.28. So if I'm going to divide this by this one to get the common ratio, 3.2 divided by 8, how much do I get? We will be getting how much? 3.2 divided by 8. That's 0.4. 0.4, that's simply 40%, which is given in our problem. So this one here is already the common ratio, which is equal to 0.4. Now, what is the first number in our illustration? The first term is the number 8. Now, here's my question. Is the number 8 found in your problem? No, it's not. That's why you need to analyze the problem, and we were able to come up with 8, which is our first term. And the value of n, 5. Now, here's our problem. Find the total distance from the word total distance. So, meaning, this is the first, second, third, fourth, fifth. Ang total distance nga na-cover niya from here going there. Kini ang total distance. So, meaning, kini iyahang pag-bounce, mo na total distance nga itong pangitaon. And our formula will be S sub n is equal to, it's a series problem. The first term times r n minus 1 over r minus 1. So, substituting everything here, the sum of the first 5 numbers, the first term is 8. We have r, that's 0.4 raised to 5 minus 1 all over 0.4 minus 1. So let's compute this. So we have 0.4 raised to 5 minus 1. Multiply that by 8. Divided by parenthesis 0.4 minus 1 close parenthesis equal. We will get 13.2 for this. So the answer is the total distance the ball has traveled is 13.2 from the first, the second, the third, the fourth, and the fifth time it bounced. Okay? Let's have our last problem for this session. So we have now a contract specifies that Lancelot will receive a 5% pay increase each year for the next 30 years. She is paid 120,000 for the first year. Let me write it down. 120,000 for the first year. So how much will he be receiving during the second year? To get that, that's very simple. I will get 5% of this, meaning 5% is simply 0.05. So I'll multiply 0.05 for that. So the result is 120,000 times 0.05. The answer is 6,000. What will you do with 6,000? I will add 6,000 to 120,000. So meaning I will be getting 126,000 for the second year. If I'll be getting the result in the third year, so I'm going to be focusing on 126,000. 126,000, i-multiply na ako 0.5. The result is 126,000 times 0.05. You will be getting 6,300 for that. And I will add that to 126,000. So, plus 126,000, you will be getting 132,300. Okay? Now, let us get the common ratio. The common ratio is 126,000 divided by 120,000. You will get how much for that? 126,000 divided by 120,000. That's 1.05. Now, 1.05 can be written as 105%, right? Now, here's my question. Without showing this one, how will you get 105%? So, it's so simple. A while ago, we subtracted 100% by the given percent. This time, because of the word increase, I will now add 100% plus 5%. That's why we will be getting 105% for that, which is written as 1.05. Now, here's another technique. If it's the word increase or appreciates, if it's about increasing, magkata ko ang number, plusan na nina ko og 1 ang decimal form sa 5%, which is 1.05. Okay? So, meaning, the solution is simply 1 plus 0.05. It will give us 1.5. Now, let us now, this is now still a series problem. We're talking about the total lifetime salary. So, S sub n is equal to the first term, that's r raised to n minus 1 all over r minus 1. So, S sub 30, because our n will be 30, this one over here, our first term is 120,000. So, our first term is 120,000. Multiply that by r. R is 1.05 raised to 30 minus 1 all over 1.05 minus 1. Let's calculate everything now. Let's start with 1.05. Exponent is 30 minus 1. Multiply the result to 120,000 divided by the quantity of 1.05 minus 1 close parenthesis. You will be getting 7,972,661.7. So this will be the total lifetime salary over a 30-year period. Okay? So just take note, mag-plus taani kung increase, mag-minus taani kung decrease. And that ends our session about problem solving. Till the next video, guys. Bye-bye.